Today, I'll tell you a bit about getting started with machine learning using Azure Machine Learning Studio and Kaggle competitions. And I'd like to apologize. I think I could have come up with a longer title, but I just didn't have the time. So yeah, this is all I could come up with. But basically, yeah, I'm going to go into this a bit later. But first, I'd like to introduce myself and maybe also find out something about you. I'm Vlad Iliescu. I come from the sunny Romania, but I hear it's raining today, so same as here. I'm an artificial intelligence MVP, and I work at this small but badass company called StrongBytes, where we do a lot of cool stuff for clients large and small. And that's it. Pretty much. What interests me more is some things about you, basically. I would like to know, for example, how many of you are developers? And managers? Good. Okay, nice ratio. So a vast majority of developers with some managers. And who is neither? What do you do? DevOps, right?
No, I'm a team leader for IT service desk.
Yes, but team leader, I think, qualifies a bit as a manager.
Yeah, well, I also do a lot of scripting.
And scripting. So, yeah, me too. But I also have a bullet list. I heard these are the latest rage. So, do you have any experience with machine learning? Could you raise your hand, if so? All right, nice proportion. With Python, maybe. Cool. Machine Learning Studio? Well, that's what you're here for, right? So not as many people. Yay, my people. All right. Well, this is the only Hitchhiker's Guide to the Galaxy joke in this presentation, I promise. All right. So some details about this talk, and sorry, I will move. So I shouldn't do that. So basically, it's getting started with machine learning. And we're going to talk about how to get started with doing machine learning, which a big proportion of you have already checked. Yeah, I'm going to use Azure Machine Learning for this. And I'm going to use Kaggle competitions. Do you know Kaggle? Who is familiar with Kaggle? Not as many people, but still a nice percentage. For those who aren't familiar, Kaggle is a community. It's an online community of data scientists, machine learning practitioners. That, amongst the tutorials and the resources for getting started with machine learning, also hosts a lot of competitions. And I will use one of their competitions. I'm going to submit results in real time and see how far we can go with Azure ML Studio. Yeah? So I'm going to, during this presentation, I will analyze the data set for one of their competitions. I will train a model based on this data set, run a model for their competition, and see how well it does. Yeah? All right. And also, pretty please with sugar on top, ask me anything. So raise your hands if something's not clear, if you feel like I missed a detail or something like that. Ask me a question. I really love having a discussion, not just a monologue. Yes? All right. I shall move again. All right. So, and I just spoiled this for you, but basically, this is my plan for today. So I will ask an interesting question. I will get the data, and you know where I'm going to get it from. I'm going to explore it, create a model, and then, well, win points. Sorry? Another, but sometimes I think I'm funny. So I realize not everybody agree, but I laugh in my head a little. So yeah, this is good. All right, but basically this whole plan is the data science process. Yeah, it's formalized by two Harvard professors, Joe Blitzstein and Hans-Peter Feister. I'm sure I mispronounced that somehow. But basically, this is actually a framework. Yeah, it starts with asking a question, getting the data to answer that question. Yeah, exploring the data, creating a model, communicating and visualizing results. And the really nice and important part is that it's an iterative process. Yeah. So at every step, we can go back Yeah, maybe our model does not perform well enough. Yeah, we should ask another question, or we should get more data, or we should do some more feature engineering, yeah, transform the data. And we're going to try to follow this process. Okay. Questions so far? Yeah, there will come. All right. So let's ask the interesting question. And before we ask that, has anybody read the description for this talk? A total of 4 people. So what is the interesting question? 5 people. And you don't know the interesting question.
It was the Titanic question.
It was the Titanic, yes.
What is the question?
We know the answer. Well, who would survive the Titanic? Basically, so machine learning is all about predicting the future, but I figured it would be significantly easier if I were to predict the past, because I don't have to do anything, really. So yeah, the question I'm going to ask is, who would survive the Titanic? And for this, I will use the data from Kaggle's Titanic competition. This is, let me just go into some detail. And it went to another screen because that's what they do. Yeah, so this is one of their getting started competitions, one of their tutorial competitions. It doesn't come with money prizes. So most of their real, serious competitions come with money prizes. This is just for learning. Yeah, so it has more resources, but not a lot of incentives to compete, other than, well, learning. So I will use the data from here. I will download the data set and try to do some predictions. OK, back to PowerPoint. But first, before we download the data, let's take a look at the features. Yeah, at what we have available so that we can predict whether or not somebody would survive the incident. And I'm going to enumerate the list of features quickly so that we kind of know what is there. Yeah. So first off, we have a passenger ID. This is the unique ID of the passenger. Not really great when doing predictions because they're unique, but useful when evaluating our results. And we'll find out why in a second. Another feature is the survival. Yes, 0 is bad, 1 is better. Yeah, and this is this is our label feature, the feature we are trying to predict. Yeah, we will train our model on all the other data just to predict this one. We have a passenger class. Yeah, if it's 1, it's first class, so the lower the better. Yeah, first class, second class, third class. Sex, so gender right here, it's male or female. Age, which is the age in years. And if it's less than 1, it's fractional. All right? SIBSP, which is the number of siblings and spouses aboard the ship. I don't know why they split this like this, because we also have PARCH, which is the number of parents and children aboard. So either siblings, spouses, or parents or children. I get it now. So it's vertical. SIBSP is vertical relationships, and PARCH, and this is horizontal, not vertical, but it's been a long day. All right. The ticket number, of course. I'm really curious if this will work. And the fare, yeah, how much you paid to get on board and then survive. Cabin number, of course, and apparently there were several ports of embarkation, yeah. Cherbourg, Queenstown, and Southampton. OK, so this is a demo-heavy talk. So now what I'm going to do is I'm going to switch to Azure ML Studio, explain how this works a bit, and see how we can solve this problem with what we know so far, without trying to think very hard. Yeah? All right. And I'm going to switch over to the mighty Firefox and ask, do you see anything in the back? And I'm going to assume no. I'm going to continue to assume no. Yeah, you can see it. Because I was going to ask what it says right there. OK, so I think this is the max we should do. Basically, this Azure ML, and I shall move again. Sorry. This is what Azure ML Studio looks like. Yeah, it's a very visual tool. It's targeted for experiments, for quick wins. Yeah, it's built for speed. You can get from an idea and the data set to a running web services in something like 10 minutes if you don't do a lot. Yeah. So it's really built for speed, but it does have some drawbacks in that you cannot, when trying to do more complex experiments, it breaks down a little. You cannot reuse things a lot. Yeah, depending on what you're trying to do, it might help you or not. Yeah, but for getting started, for running experiments, for running proofs of concept, so nice, right? All right, and this is a sample experiment. Yeah, the main unit of work here is the experiment. This is what we're going to look at. And what I've done here is I've downloaded the data set from Titanic. Yeah? Because on Kaggle, I can download a training set and a test set. And I'm training a model on the training set here. So how this works, what I'm trying to do in this experiment is take the training set, train a model on it so that it can assess its accuracy, then run that model on the test set that is provided by Kaggle. Because how they're calculating your scores in this competition of theirs is they give you this training set, you build a model, you then run your model on their test set for which you don't know the answers, you upload the results to their website, and they're calculating your accuracy. And the better the accuracy is, the higher on their leaderboard you get. Yeah? All right. By the way, questions so far? No. All right. OK, so what I've done here is load this training data set as a CSV, and let's look at it a little. Yeah, we can see the columns that I've mentioned before. Yeah, passenger ID, survived, P class, names, everything. We can see that we get some statistics, how many rows we have, how many columns. Yeah, we also get some numeric statistics for the numeric features. Yeah, the mean, the median. Well, but basically, SIBS isn't really it can be seen as a numeric feature, let's say. Yeah, and also we get some charts. I won't look into this right now. We'll be back in a jiffy. All right, so what I'm doing next is, I just realized I haven't explained how this works, right? But you said you don't have any questions. So what up?
So far, so good.
So far, so good. Yeah. But does this make sense?
I want to see what you're going to do with the edit metadata.
What were you supposed to say? Of course, you want to see what I'm going to do with edit metadata. Yeah. But basically, how this works, and sorry for not explaining this, is a visual interface, drag and drop modules. Each have one or more input connectors and output connectors, and you just drag and drop. Yeah, so you have this huge library of pre-built modules. Yeah, data format and input. For example, if I want to load the data, I don't know, from an Azure Blob or Azure Story, yeah, or Cosmos DB, I can just use this module. Yeah, if I want to load the train model, I have this. If I want to run any statistical functions, if I want to train models, I also have a lot of models here, yeah, pre-built, which I can just connect with other modules so that in the end I get a working solution. So that's how it works. And also, if I do want to write some code, as we'll see in a moment, I'm also able to do that. Yeah, in Python, R, or SQL. Who doesn't like SQL? Yeah. So back to the edit metadata thing. I'm not doing a lot. Because what I'm doing here, and I found it interesting, is that survived at the moment has two values. Yeah. So it's 0 and 1. And if you're not going to ask me any questions, I'm going to ask you. Yeah. This is how it works.
The siblings and the parents, are they just the number, or are there relationships modeled in there?
So if the siblings and parents are just numbers or if they represent a relationship.
It's the relation to the parent, and then you can see.
It's not an identifier.
No, okay.
It's not an identifier, but you can look at the last names. So you could build, in theory, the tree, the relationships tree. I haven't done this now. But this is just a number, how many siblings you have on board, right? Okay.
How many survived?
But let's see. Well, it says here that about 342 elements. But that's just for the training data set. So, but these percentages represent the distribution of the entire data set. So from what I've read, it's something like 33% survivability, if I remember correctly, which I often don't. So, but I'm still going to ask my question. So, do you have any other questions? No. Okay. Here go I. Survived can only have two values, yeah? 0 and 1. That makes it this, what kind of a machine learning problem? Is it a regression, classification, or clustering problem? Classification. Why is it a classification problem? It's a fixed number of options, and you don't have to predict a number through a continuous number. Yeah, so it's a classification. And specifically, what kind of classification? A binary classification, because it only has two classes, yeah? Yay or nay, basically. Right? But at the moment, we can see that Azure ML Studio thinks that this is a numeric feature, and it draws a chart for a numeric feature. And whereas I could coerce it somehow to display the chart properly by changing the number of bins here. Yeah, you see? Much better. It's still not right. Yeah, it thinks that, well, it thinks that 1 is better than 0, and in this case, it actually is. But we should make this right. Yeah? So I'm making this right by editing the metadata, selecting a column name, all visual, all really nice. Yeah? I only select survived. And then what am I doing? I'm changing this as categorical, and I'm also telling it, by the way, I kind of want to predict this. Yeah, it's a label. And after this module is run, yeah, I can select visualize and nicer charts. Also, one other thing, I can start comparing. Well, I could before, but now the charts look better. I can start comparing the survivability with the other features. Yeah, I can try to see whether there is any correlation here. I can start doing feature analysis and determine which features help me and which don't. But more on that later. All right. So what am I doing next? I'm splitting the data into two data sets. And why do I do this? I told you I would be asking questions. I will get a test set and I will see the answers. But basically, what I'm doing now is split the training data set into two subsets. And I'm using one to train a model, yeah, because I'm training logistic regression and connecting it to train model. Yeah, and the other I'm using to score the model, score the train model. And why am I doing this? Well, couldn't I have seen how good it is just connecting the entire data set over here? This way it would have more data.
You already do that on the right side.
You notice more than you should. Yes, I'm already doing that on the right side. I should have zoomed a lot, but. So I'm going to have to answer my own question. My model, thank you, who said that? Do you want a sticker? I think it was here from before, but it's a nice sticker. It's happy. Well, part of it is happy. Yes, I want to see. So if I had fed the whole data set to my train algorithm module, yeah, I would have trained a model that knows everything about our data set. And then I would have I couldn't have evaluated it. I couldn't have seen how well it generalizes to new data. Yeah, how well it handles data that it hasn't seen before. And this is what we want to do, because we're going to run it on data it hasn't seen before. Yeah? This is why I'm splitting it. Otherwise, the accuracy that we compute, it wouldn't have meant a lot. All right. And by the way, if we look at the trained model, because we can also visualize this, we see some interesting things. Yeah, on the one hand, we see here the hyperparameters for the logistic regression algorithm. Yeah, it's a really, really, really basic algorithm for binary classification. But then we see also the feature weights. Yeah, we see that our algorithm thinks that being a female is very positively correlated with survivability, whereas being a male is, the good news is that it's correlated with survivability, and the bad news is that it has a minus in front. So I don't know about that. But basically, this tries to infer an equation, yeah, which it can then use to calculate 0 or 1. And these are the weights for being female, for being male, a bias, which is basically the intercept, where it cuts OY. It also thinks passenger ID is really important, and I don't think that that's the case, because yeah, then we can see that the age is kind of negatively correlated with survivability. If you're embarked in Cherbourg, good for you. Otherwise, no. So we can analyze. We can try to reverse engineer the model a bit. We can see how it was built. Well, how it was built, yeah. How it considered the features. Okay, and what happens here in score module, which is getting fed the trained algorithm and the second data? Well, our model here is being run on the entire data set. And we can see it adds 2 new columns, yeah, scored labels and scored probabilities. And the good news is that it adds 2 columns. The bad news is that we have a lot of nulls. So for something like 267 rows, most of them are null. Yeah, but I'm sure that's not an issue. We'll see. Right? So we can see that, for example, let's see, for Miss Caroline, yeah, she survived in real life, and our model thinks she survived. Yeah, it's a 1. Major Arthur survived. Yeah, our model sees he's a male. Figures, yeah, why bother? Not survived. So we can see that some of the numbers work, some of them don't. But I don't want to spend my time looking at the entire data set doing this. So what I'm going to do is call in the evaluate model that, of course, gets a score model. And this summarizes the data for me. I'm not going to go into all of this. We get some pretty charts. We can take a look and see how well it performs. What I'm going to be interested in here is, on the one hand, well, most importantly, the accuracy. Yeah, the accuracy is how many people I got it right for. Yeah, and this is what I'm going to use. I'm not going to use the precision and recall, which are really useful for unbalanced classes. Yeah, classes like, for example, the zombie apocalypse, when only a tiny percentage of the people have the zombie virus, but we need to really make sure we identify a zombie correctly. No, here we have something like 30 to 40% survivability, 60% non-survivability. I don't think we need it right now. Yeah, and we also see the confusion matrix over here. So it got true positives right 23 times. Not a lot of numbers, right? For 267 rows. So again, something smells funny with this experiment of mine. But this is how we'll evaluate them. Yeah. And well, I wish I could have uploaded to Kaggle. Yes.
When you split the data, did you split it 50-50?
Good question. No. I actually split it to 70-30. So 70% of the data goes into training and 30% goes into evaluation. So what I'm doing now is, again, the simplest thing that works. I'm going to feed the entire data set to my model because I want to build the best model for Kaggle. Yeah? So this is why I'm feeding the entire data set to the model. Because I've trained it, I've evaluated it. I saw that it has something like 70% accuracy. Not bad when it returns data, actually. Now I'm going to use the entire data set to train the model and see how well it does. Yeah? And this second train model module is also linked to my two-class logistic regression module. Yeah? And it will be run on the testing data set, which is the second data set that I got from Kaggle. Yeah, only 418 rows. Starts with passenger ID 892 and goes on and on and on. Yeah? And they require me to return a list of passenger IDs and whether or not they survived. Yeah, this is all I need to return from here. Let's see how I do that. Of course, going to run it through score model. Score model is going to add 2 new columns. Score label. Void, the infinite void is here. Yes, so it crashes and burns. Sometimes it works, though. So that's what I tell my bosses when sometimes it works. Why? If you're lucky. Okay, but this is how the score module functions. And then I need to make some transformation, yeah? Transformations. I need to get rid of most of the columns. I get a feeling I need to actually fill in those nulls, because otherwise the kind people from Kaggle won't let me submit my results. And I need to rename a module. Yeah, so I could do this in theory using 3 modules from Azure ML Studio, so native modules. Yeah, select the columns, select only passenger ID, and scored labels. Yeah, edit the metadata, rename scored labels to survived, because we don't want scored labels. Clean missing data. Yeah, I'm the optimistic type, so I'm going to assume everyone we don't know what to answer has survived. So let's see how well that works. So I could have done all this in 3 modules, but I'm going to use one of my favorite modules in Azure ML Studio, which is the apply SQL transformation, and this can do everything, really. So it can select a subset of the columns. I can do an if null and just put 1 if scored labels is null. And also I can I can rename it in one fell swoop. Yeah, so I'm going to use it here. Let me just check the results. Beautifully. What do you know? Most people survived. It's not a bad model. All right. So let's see how well this works. And I'm going to link this to convert to CSV module, which convert. What do you think it does? All right. So just download the thing. Go to the Titanic competition with my special throwaway account. And you upload the files. Let's see, it's uploading the files. Slow wireless. Yeah, they expect the solution file to have 418 prediction. Now it does. And make submission. Okay, how well do you think it did? Not so well. So there are something like 10,000 entries in the competition. Which position do you think it has? Sorry? 1,000. So in the top 10%? Yeah. Any other takers? Yes. 9,000. Who wants to go higher? It's over 11. So I'm sorry, you too many characters. I should. So there's 10,200, and I should zoom this in. So there's 10,277, and I'm at. What do you know? But thing is, I'm only about 55. So I think I'm at 10,200 position, which could have been worse, I guess. So the good news is that there are people who did worse. That, like that joke with a bear where you only need to run faster than the other guy. Machine learning. Okay, so obviously,
Just let the blanks die, then it was
yeah. The what?
all the blanks. The negative.
Yeah, it would, but then it wouldn't have been so funny. 'Cause, yes, yeah. I must admit I rigged the results a bit, but you laughed, so I'm guessing that's all right. Okay, so why did we do so bad? Well, I'm gonna say a big reason for this is we didn't consider the nulls. So if we take a look at the age column, yeah, and the statistics, we have 43 missing values, yeah, for age. And that's not as bad as the cabins, which have 209 missing values. Yeah? So every time we try to run a prediction on that data, this particular algorithm, and I'm saying this because other algorithms, such as maybe decision trees, they handle this significantly better. But this particular algorithm crashes and burns and doesn't return anything. So we kind of need to look at the data and try to understand it and see what we can do so that we can at least go a bit higher in this. Yeah? And for this, I'll open my second experiment, which has the bold title, Feature Engineering. Very bold. Sorry?
There is a Python there.
There is a Python there. Snakes on a plane. Yeah, there is a Python there. And so what I'm going to do now is look at the data. So the exploration step. And first, I'm going to run the summarize data module on this. This is a really nice module, once you see its output. That allows me to see, for example, how many unique values each column has. Yeah, so for passenger ID, as expected, it's almost 900. For survive, two values. For P class 3. And I could have seen this by clicking incessantly on each of the columns, but life is too short for that. Yeah, so I'm running this module. Also, we can see the missing value count. Yeah, for age, it's 177. For cabin, 687. Not great. We need to fix this. For embarked, also, 2 missing columns. Right? And we can also look at the distribution, the mean. Yeah, for example, I think the fare. Yeah, we can see that for the fare, so this is the fare column, yeah? The median price was 32 anything. But the maximum price was 512. Yeah, so some people had a lot of money on that ship. Okay. What's next? I run summarize data. And then, of course, our old friend edit metadata. Same as before. But now, what I'm going to do is clean the missing data. Yeah, I'm going to use the, of course, aptly named clean missing data module. And I'm going to take a look at age and fare, because we've seen that those have a lot of missing columns, or a lot of missing rows, sorry. And what I'm going to do is replace them with the median value. So what is the median value?
It's a line which separates the set into two columns.
It's the value that is exactly at the middle. Yeah, so it's not the average, but the value that is exactly at the middle. And this is what I'm going to use to fill in the blanks. I could have made a call to to remove those rows. But we don't have a lot of data. And if I had removed those rows, then we wouldn't have been able to train our model on a lot of data. Hence, I'm imputing those values. Yeah, I'm assuming they're the median and just filling them in. Yes? Why am I taking the median? Well, what could I have done better? Why not? Because it's this option right here. Do you realize how it was so easy? I think it's the default. No, but it's a good question. I could have. So I could have looked at the deviation. I could have made some random entries inside the deviation, but then I would have had to write code and explain said code, so median. I could have used mice, which is multiple imputation, and basically does a linear regression, as far as I remember, on the other rows and tries to predict the actual age based on the values on the other rows. Yes? Yes, if I don't have a problem with one value being overly represented, right? I'm a simple man with simple needs. Yes, yeah, it's a good point. The same value appears a lot of times. In my experiments, so we could have fixed this by running mice, because this tries to predict. In my experiments, for this data set, it didn't work so well. So this is why the median. But very good point. It introduces a certain bias. Yes?
Why don't you leave out those two columns?
Also a good question. Also a good, right? So I love, isn't this much better than just me talking? Yeah, why did I choose the median? Well, because. And why didn't I remove the whole column? Well, let's take a look at the results of the clean missing data. So, by the way, clean missing data has two outputs, one being the clean data set, and the other being a clean data set transform, which is really nice because I can reuse it later on if I just scroll here. Yeah, so it's a way to reuse modules. Okay, but let's take a look at the results for clean missing data. Do you think age correlates with survivability? Intuitively, it should, right? Because women and children first, so able-bodied man, go swim. Yeah, what if we compare this to survived? And we see that it's not particularly correlated. So yeah, the middle line is the median over here. And again, sorry for moving so much. The middle line is the median, and it's kind of the same for both. Yeah? On this part, we have people who didn't survive, people who survived. But the lower percentile, the lower quartile, sorry, 25%, is for those who survived, indicates that younger people, well, they fared better a bit. Yeah, so we do have a correlation also. Yeah, the upper whiskers. But age as it is might not be as good. So I'm not dropping age because I see a small correlation. And I think that we could maybe transform this column so that it can perform better. We'll say that, again, in a moment. Well, maybe several more moments. But sorry, did I answer the question, and are there any others? He went first, and then, yeah, sure.
You're filling missing rows, but passenger class was the biggest missing row. It's not filled in this one. It's only age and
No, passenger class actually was filled in.
It's room number.
The room number, yeah, terrible. Yeah, nice observation. Yeah, the cabin, well, this is useless. Because most of the cabins, well, let's take a look. Let's see how the cabin looks like. For clean missing data, So the cabin kind of looks like this. Most are nulls. Apparently, a lot of people share G6 for reasons. Yeah, you could, in theory, let's say, derive the deck that the cabin was placed on based on the first number. It's a possibility. That's a decision you should make after evaluating the performance. Another is just drop the column because a lot of rows are missing. So 77% of the rows are missing. So how valuable will the remaining rows be? Because if I've introduced bias while picking the median for age and fair, this will be even more biased. So this is why I didn't do anything with Cabin.
Okay.
Yes.
You could make a new model to guess the age of the people.
Based on whether they survived or not. You look like 5. Yeah, but maybe. Yeah, but you should do that. Right. Other questions? No, so far. All right. Well, so after this clean missing data thing, by the way, I'm also setting the option here that columns with all missing values, which is not the case here, but just to show you that you can. We should remove columns that have all missing values, right? Because they're useless. Okay, and what do we do afterwards? Well, afterwards, we execute this cool Python script, because you can execute cool Python scripts. So let's do it. So what this gets, it has 2 input ports for data sets. You can do all kinds of joins and stuff. And another port for a script bundle. The cool part about this script bundle is that it allows you to upload your own scripts and have them unzipped and use them in the virtual environment that's being created in order to run this. Yeah, I haven't used it here, but you totally can. So for example, yeah, you can install the Kaggle command line interface and use it from here directly, assuming you have a pip environment. So what I'm doing here is make some small modifications. And you'll have to believe me, they help. I also had the Jupyter notebook highlighting this, but I figured, let's be focused. Right, so what I'm doing here is first fill the 2 columns, the 2 missing values from embarked with Southampton. Because, and again, you'll have to trust my word, this is the best choice. Right? Afterwards, I take a look at the names and extract some titles, because not sure if you've noticed, I probably have. Names include titles. Yeah, a Mr., a Mrs., a Miss, Mrs., Mr. How about to extract this into a title column and see whether or not it influences the survivability? Well, if it influences, it's correlated. Yeah, so this is why I'm extracting the title here. And by the way, I'm also creating a new variable with family size on both a horizontal, and now I got it right? You notice, horizontal and vertical scales. Right. Yeah, so I'm doing this simple Python. I get the data set as a pandas data frame. Just do some entire columns operations. Yeah, so I don't have enough problems, so I'm using regular expressions here. And then I just made some small replacements, because I get a me, which actually means miss, I'm told. Miss, miss. Yeah, so I'm replacing all these, let's say, exotic names with more common titles. And then and you wouldn't believe it, we have titles such as John Keir. Jesus. Yeah. Yeah, or Don. Don, right? This is the best title ever. Right? So I'm aggregating all of these as, other, I think. As rare. It sounds so much better than other. Yeah, such Joe or Sir or Major. Yeah, and also I'm, as I said, creating the family size variable by aggregating sibsp and parch. Yeah. And how does the data set looks after this? Better, of course. Yeah, I have this. And let's see if the title correlates with survivability. Bad time to be called a Mr. But I can see that, yeah, you can see that Mrs. and Mrs. survive better. So it's an indicator. Yeah, it might be an over, so I might add more, just a moment, more importance to the gender field, right? Because some of the titles are really gender specific. But it might also be provide some new info. Yes?
Could you please show correlation with the gender?
Just to make sure I didn't screw up, right?
Yeah.
You see? Well, so Mr. Male, Miss, Mrs. Master are males because children. Yeah, Master John. And the rare, whatever. Let's go. Yeah, so it is, told you it's correlated. Yeah, and how does the family size correlates with survivability? This is interesting. So apparently it was good to have a number of family members aboard the Titanic up to a point. Yeah, so at around 8 people, it didn't work so much. Yeah, because we see the outliers. Yeah, but family size, you can see it positively correlated with the survivability. So let's skip this. All right. What I'm going to do next is select some columns in the data set. So not all the columns. Yeah, I'm just going to skip passenger ID, name, ticket, and cabin. Because I think you've also seen the tickets are terrible. And of course, I'm visualizing the results which don't have any tickets, just to prove a point. Yeah, so this is how the tickets look like. So they do seem a bit, well, random. Some are numbers, some are not. Some start with PP, others, well, with PC, and so on. Terrible. So I'm not going to try to infer any information from them at the moment and just exclude them. Yeah. So I'm going to go to my old friend 2-class logistic regression and train a new model based on the new data set, and let's see how well it does. And we see that, well, for once, the accuracy got better. And for twice, we have a significant number of, well, results as opposed to what we had before. Yeah, so things are going well. Also, let's take a look at score model and make sure we don't have any nulls. Yeah, scored labels, missing values, 0. I did good. Okay, so we're going to take all this data set then and do some more things, because why not? Yeah, so first I'm going to use the apply transformation module and apply the clean missing data transformation. Yeah, because I want the same data. I want the data from the testing data set, the missing data from the testing data set, to be filled in with the same median as I had filled in the training data set. Yeah? This is why I'm reusing transformation. And also, if you notice, in the clean missing data set, it handles 2 columns, age and fare. However, we don't have missing fares in the training data set, right? We can check for that. But you believe me, right? But we do have missing fares in the testing data set. Yeah, so I'm filling in those missing columns. Yeah, that missing row, with a median value from the training data set. Yeah, this is what I'm doing here. Of course, then I'm selecting the columns in the data set, and unfortunately, this doesn't get the transformation. So I have to repeat the same columns as I did before. Or not. Okay. Apply the same Python script, which, again, I could have saved locally, uploaded it as a zip file, but it was just too much work. And I couldn't have, I'm lazy, and I couldn't have demoed this as well, right? So I'm repeating the code. Yeah. Run everything through score module. And then my trusty apply SQL transformation, convert to CSV. Yeah, let's see how well this goes. Upload the files. Upload is being initialized. Not going to ask you how well you think it does, because it did better. Yeah, so top 50%, which realistically speaking is not great for a training competition. But let's enjoy the little things, right? Top 50%. Yeah. and it's also not an improvement of my best score. Yeah, so what did we do? We looked at the data, we tried to understand it, we eliminated missing values, we created some new features, and then we got better results. Yeah? Let's see if we can improve them. But any questions before we do that? Yes?
How come so many people have exactly the same score?
They're cheaters. No, it's not a big data set. So why do people have exactly the same score? It's not a big data set. So, and the testing data set, it's even smaller. So you're bound to run into the same. Plus, it's a binary classification problem. So you can only get 1 or 0. But if, sorry?
Who ends up first if you have 10 with the same result? Is it like,
I think it was the first person who submitted that, I think, but not. I'm starting to wonder about that because 2 hours, 6 minutes, right? So I'm wrong. But
Usual real competition Kaggle always places the first pointer the highest.
so you said that in regular Kaggle competitions, the first are the highest.
Always the first goes.
So basically what you're saying is that I was right, just not in this case. Yes, yes. Thank you. Okay, but again, if we look at the top predictors, I don't think these guys are doing it for reals. Yeah, because you can also download the entire data set and just submit it here, by the way. I did that. I was one of the first. It was awesome. Yeah, so you see so many people, perfect scores. Wow, more than 50. Anyways, other questions? And I'll have to remind you, this is going to end soon, so if you have any good questions, now's the time to ask them. A good question, please.
There was another method?
We don't talk about that. No, I said that.
Which methods you're using right now?
Another method. So you said that I said that there was another to create a model.
You said there was also a tree method.
There are other algorithms. Yes.
What was this algorithm?
Logistic regression. This. I'm using I think one of the worst algorithms that I could have used in this case. Again, just to prove a point. So I could have used a better algorithm, but I didn't want to.
And how do you decide on the algorithm?
Step 1, know what you're doing. Which, not my case. No, so I would look at the data structure, yeah, at how many features I have, at how many rows I have, at the distribution, and try to pick one. Basically, I would also always favor, for example, decision trees for this kind of problem. But maybe you get another algorithm like, I don't know, boosted decision trees or LightGBM for this. It also depends on your experience and, how you get a feel, how you interpret the data set. What you can do if you do have experience with Python is use the automated ML library, that was recently released for ML service. And that basically is a recommendation engine for your data set. And it does recommend a series of algorithms and the combinations of algorithms and hyperparameters that, in their experience, perform best for that data set. So, and that might give you a baseline on which to start. Yeah? Okay. So I'm not going to go through all these examples, just one tiny last one. And I know it's tiny because I haven't zoomed in. So zoom in. So what I'm doing here is basically everything I've done before with one important addition. Yeah, I'm going to group the data into bins. So instead of having ages from 0 to 82, I'm going to split the ages into 5 groups. Yeah, 5 bins. How this looks like, and I do this for both age and fairs. Yeah, how this looks like gives me a column age quantized. This is what it looks like. Yeah, the first interval is the third most popular. Yeah, we can see, and I think these are people from something like 16 years to something like 26 years or 30. Yeah, these are the most. Older people, next up, and so on and so off. And if we take a look at correlation between this and the survivability, we notice that at least for our second bin, yeah, for our second group, there is a correlation. Yeah, if you're young, you did have a chance. But if you're a bit older and could take care of yourself, fat luck. Yeah, and then it evens out. Yeah, so I created a new column by grouping this data into buckets, yeah, bins. And I did the same with fares. Yeah, and we see that number one was the most popular fare, so people paid as little as possible to get on board. But there were also some other big spenders. Cheers. Yeah, and we can see that big spenders, well, some of them got their money's worth, right? Okay, and afterwards, everything is the same. Yeah, I group the data into bins. This gives me a quantized data set and, luckily, a transformation, a binning transformation. I select the number of columns, also run the binning transformation on the testing data set from Kaggle. Yeah, so I need to run the same transformations, all the steps on both the training and the testing data set. Yeah, otherwise this doesn't work. Our model doesn't have the necessary fields, yeah, and it needs to have the same fields. Okay? Run the Python script, train, score, select columns in data set, convert to CSV. Download this, and do you think it fares better or worse? Worse?
We introduced more data.
This is actually the best performing model I have. The others, the ones that you're not going to see, are worse. But this is actually better.
By adding the bins, did you remove of the age?
Yes. Yes, I also ran select columns in dataset afterwards. Because otherwise, if I didn't remove the age, I would bias the model and have it consider the age almost twice as important, right? So we didn't want to do that. Yeah, so I'm in top 20% with a small modification.
1.5.
Sorry?
Top 21.5.
Yeah, but it sounds so much better if you don't say it like that. Right? Okay. So this is what we did. I'm going to tell you that by the end of the week, I will put this write-up for this talk. And most importantly, the experiments that we've just run, because you can share them and you can try them for yourselves. I'll put them on my website, which is vladilescu.net/studio and Titanic. I'll also upload the site to the Ignite portal. The slides. Yeah, so it's okay if you want to take pictures, but you'll also find them there. Yeah, so just so you know, by the end of the week, you'll be able to play with this. We have 2 minutes in which you can ask me anything, basically. And I will not just answer 42. Yeah, but if there are no other questions, I'd like to thank you. And, well, thanks for coming.